In the woods is a cellular receiving tower that is 72 foot tall and has a shadow of 60 foot. Next to it is a tree with a 40-foot shadow. How tall is the tree? Okay, so we can draw really great pictures, or we can just draw pictures enough to get us through. So the first block, I'm going to draw a picture. Okay? I have a tower, and it's 72 foot tall. And it has a shadow of 60 foot. Then we have this tree. We don't know how tall the tree is, but I know that the shadow of the tree is 40. And it's asking me for how tall the tree is, so it's asking me for x. So I can make that a triangle if you want to, or you can leave it like that. I can already tell that I have matching sides and matching, the bottoms are the same and the tops are the same. Okay, so the proportion is the equation that you use to solve it. So how are we going to solve it? What would you write in that proportion box?
72 over x equals 60 over 40.
Okay, and then we solve it the way that we have been. So when I do 60 and x, that's 60x. When I do 72 and 40,
It's 2,880.
is that what you said, 2,880? Divide by 60, 40,
48.
and you get 48. And so then the answer just goes in the last box. So we draw a picture, we write an equation to match the picture, we solve it, and then we get the answer. Okay, questions about how I drew the picture or why we did what we did on that? Okay, next. This person is making a scale drawing for his architecture class. He's using the scale 1 inch to 8 feet. What that means is that he's making this drawing, but he's making it to scale, so everything on there matches up with what it really should be, but we just made it smaller. Okay? So it means that his drawing and the real thing are similar. Okay? So 1 inch goes with 8 feet. The building in the drawing is 9 inches. How tall will the actual building be? Okay? So we're trying to match up inches with feet, because the how much will it really be is our feet. Okay? So our picture here, we can draw a picture kind of like we did up there if you want to. Like we could say, okay, 1 inch to 8 feet. So 8 feet would go here and 1 inch could go there. Okay, it tells me the drawing has the building at being 9 inches, so I could put 9 inches here, and that means I could find 8 foot there. There's one way to draw the picture. You could draw the picture however you want to. It doesn't necessarily have to be set up the way that I drew it. But that's one way just to get everything together so that you can see what you would divide. Okay? So now, make our equation. Somebody tell me what equation we would have there. Good. Okay. So then we multiply and solve. So cross multiply. So x equals 72. And that's what goes in the answer box. Okay, let's read the next one. A wheelchair ramp is 9 feet long and sits 2 1/4 feet high. How long will a similar ramp be if it is 1.5 feet high from the ground? Okay, can you tell me an example at our school of a wheelchair ramp? So right up here, past Miss Harmon's room, that ramp that's going up. Okay, when it talks about the length of the ramp, it's talking about from start to end how long it is. When it's talking about the height of the ramp, it's talking about how high it is from the ground, how high it goes up at the top. Okay, so if I think about a wheelchair ramp, I'm thinking about this triangle maybe. And the ramp is the sideways, the slant, and the height is the up and down. Okay? So the ramp is 9 feet long, so I'd put 9 on the hypotenuse. And 2 1/4 feet high. How can I make that 2 1/4 to make it not be fractions? 2.25. And if you didn't know, you could put 1 divided by 4 in the calculator and do it that way. But okay. How tall will a similar ramp be if it is 1.5, not how tall, how long, sorry, will a similar ramp be if it is 1.5 feet high from the ground? So we've got that picture, and we're looking for the length of a different ramp where the height is a different height. Okay, so somebody different, tell me how you would set that one up.
9 over x and 2 1/4 over 1.5.
Good. All right, let's cross multiply. So we get 2.25x equals, multiply 9 and 1.5. And then divide by 2.25. And what do you guys get? 6. Good. Next problem's kind of nice. They already drawn the picture for you. But let's read and see why they drew the picture. It says triangles ABC and DEC are similar. How far is it from point A to point D? Why is it that they drew the triangle or the picture? Well, the words don't really tell you anything. The words don't tell you any information like what anything about the sides are. So that's the reason the picture is drawn. Okay? So if this is 25 and this is 20, it's asking me how far is it from A to D. So what does it want to know? A to D. It wants that whole side. Right. So I'm going to have to find CD, set it up, find CD. And after I get CD, then I'm going to add it to the AC because it wants that whole side. Okay? It's wanting this whole side. So I need to find that bottom part of it using our triangles first. And then once I find that bottom part, then I'm going to add 25 to it. Okay? You guys try that one. Okay, Logan, how did you set it up?
I did 20 divided by 12 equals 25 divided by 8.
Good. So then you cross multiplied.
Once you do it all out, it equals 15, and then you add 25 to get 3.
Okay. So you get 15 for x, and then you're right, you add 15 to the 25 to get the whole side, so you get 40. Good job. Any questions about that one? The length of the bedroom. What numbers actually do I even need in this problem? I don't need all the numbers they gave me. I need the 7 for sure because 7 is the length in the scale drawing. Do I need the 6? It's asking me for the length. Do I need the 6? 6 has to do with the width, so I don't need the 6. And then I need the 2 and the 4, right? So the picture here, it can be kind of like the picture that we did above with the inches and feet if you want it to be. Like 2 centimeters, 4 feet. And then the 7 centimeters is going to go where centimeters is with up there with the 2, and we're looking for the feet. So then if we set it up, we would have 2 over 7 equals 4 over x. Cross multiply, so 2x is 28. Divide by 2, you get 14. That means that his bedroom is 14 feet long. Alright, we're going to talk a little bit more about perimeter tomorrow, but we're going to do this problem in just the normal way, and then we're going to talk more about perimeter. This one is talking about finding the perimeter of Julia's bedroom. So what does that mean when it says perimeter? Like all the way around. So if I know a length and a width, I have to add the length, the width, and the width all together. Okay? So in this problem, I know that the brother's is 12 foot long and 10 foot wide, and I know hers is 10 feet long. So what are we missing? Her width. If we can know her width, then we can find the perimeter. Okay? So I'm going to make a square just because I know the bedroom's probably not a triangle or a rectangle, some kind of like that, because I know it's not a triangle. And I'm going to say that this is Julia's and this is the brother's. So the brother's I know is 10 by 12. And I know that Julia's is 10 feet long, but I don't know the width. Okay, so let's set it up to find the width. X over 10 equals 10 over 12. Cross multiply, you'd get 12x equals 100. And then you divide. Okay, and what that tells me is that Julia's width is 8.33. So if all I want to know is her perimeter, then I'm going to take 10 and add it twice. And then I'm going to take the 8.33 and add it twice. And then that right there should be the perimeter.
It's 36.6.
So you get 36.667 if you want to do that. Between area and perimeter and triangles and similarity, and we're going to talk more about it tomorrow, but any questions about that one?